Okay, so in this week's tutorial, what we're planning on doing is taking the design of our handle front that we worked on last week, so that is this half of the overall handle, and then using a module within Creo which allows you to produce moulding tools from your designed parts. So the area that we'll be working from is here in the learning materials, just after last week's material. There's a screenshot here of what we're hoping to achieve by the end of the session. So hopefully you can tell this is a two-piece mould, and it will create the part that we've just talked about, the handle front that we were working on last week. So before we get started, if you just want to go back to the top of the page and take a save of the config.d.pro, so that would be this file here, and then when you've booted up Creo, you need to apply that file just to set all the config options. Otherwise some of the activities that we're going to do in this tutorial won't work properly. So I'm going to apply that now. So File, Options, Configuration Editor, Import, find where you've saved the file to. So there's my file in my work directory. Click on OK, and then click on OK again. And if you get this pop-up, you can just answer no to that. You don't have to save that file again. You can just answer no. So now what I'm going to do, I'm going to set my working directory. Now I've already done this before I started recording this session, so you can see I'm just working in my documents and in a folder called Creo Work that already has some files in there. And then I'm going to go back to the learning materials, scroll down to where we're working this week, and I'm going to do two things. I'm going to open up this PDF here, because that's what we'll be working from. So if I middle click on that, that will open up in a new window. So that's just loading in now, and that's what that should look like. That's the first page of the PDF, and I'm going to need to download this part file as well. So if you right click on that, save link as, and then navigate to wherever you're going to save it. Now one thing that you have to be careful of here is that some browsers, Chrome included, or Firefox, often add extra brackets and numbers into the files that you download. So you can see here I've got a brackets 1 close brackets, and if I don't delete that like that, Creo won't be able to recognize that file. So you have to make sure that the file that you save is named exactly as it's shown there, handtoolfront.prt.3, and then you can save that into your directory. Now I already have a copy of that in the directory, so I don't need to press save there. So let's get started on the actual tutorial itself. As I've already said, what we're aiming to create is this two-piece mould, and in order to do that within Creo, it's a multi-step process whereby you start with the part design that you already have. In our case it's the handle front, and then you gradually build up the geometry that you're going to need to fully define the size and shape of this moulding tool. So that's the kind of broad outline of the process. I've put a slightly more detailed outline here, and this is quite useful if you're having to replicate this process at any point for your own projects, let's say. If you just remember to work through these 9 points, then you'll have covered all the major steps required to actually produce these two halves of the mould. Now there are other steps that we're not going to go into in this tutorial that add further details to the mould, such as runners or mould clamping fixtures and various other things that you would want in your mould, but this covers the basic steps of producing that two-piece moulding tool. So I'll keep momentarily referring back to this PDF guide, but I won't necessarily view all the steps, but you can keep this guide. You can work through it at your own pace in conjunction with this video or just on its own, so that is entirely up to you, but the guide is reasonably comprehensive in terms of the steps that we have to go through. So the first thing that we're going to do is create a new file, so that is this step here. So I'm just going back to my Creo window. There's Creo. So I'm going to go new file. What sort of file? This is going to be a manufacturing file, and the subtype is going to be mold cavity, because that is what we're trying to produce. And then I'll probably give this a sensible name. So this is a mold for the handle, so I might call it handle FR for front, and then it's a mold tool, so I might put the word mold at the end of it, so handle front mold. Click on OK, and then depending on what systems you're using and how those systems have been set up, you may be confronted with this screen. This is essentially asking about the unit system that we want to use and the part template. So I'm going to use millimeter newton seconds. So yeah, if you select the same option there, that will be fine. Then we get dropped into the mold creation environment. It's very much like the standard assembly environment that we've already done some work in. We get our three datum planes here, so we get a right, what is essentially a top plane, and a front plane, and then we get a default coordinate system as well. And the first thing that we're going to do is we're going to bring in a copy of our finished part. So we're going to point the system at our finished part file and tell it that that is the part that we're hoping to create a mold for. And then what the system will do is it will import that part, but it will import it as a copy. So that ensures that we don't accidentally make any changes to the part or maybe delete the part. So it creates a linked copy of the part. And when we do this, we refer to the imported part, this copied part, as the reference model. So we're going to click on this button here, reference model. The system will then browse to our working directory. You can see I already have the handle front in that working directory. If you're not sure at any point what these files are, if you'd like to see a preview before you open one of them, you can click on preview down at the bottom there, and you get a nice 3D preview of any Creo files before you load them in. So that's quite a nice little extra feature within Creo itself. So I'm going to open this part now. Then I get confronted by this next screen. Essentially what this is asking is the copy of your part. Do you want that copy to be linked back to the original part? And we can have that link bidirectional, which is this default option that's been selected. Or I think probably slightly safer for us learning how to use this tool within Creo is to select this bottom option. So select inherited. What that essentially means is the original part can affect the copy of the part that we're about to create, but the copy cannot affect the original, which is probably a slightly safer way for us to work. So inherited. Click on OK, and then at that point we should be able to press preview and we can see where the part's going to be placed by default. Now we can play around with that placement, but I think for this tutorial we'll just accept the default location. So OK. The system will then give us a warning that it's modifying the accuracy of the system. We can just OK that warning as well, and then we can close this little menu because we've concluded those first steps that we're going to do. So the next steps that we're going to do next is that we're going to put a block of material around our reference model. So here's our reference model that we've just imported. There it is in the model tree. the next step is to essentially block out the final outside sizes of the mould itself. So you can see that given that we're producing a two-piece mould, when the mould clamps together, the two halves of the mould, their external shape is essentially a cuboid that is bigger than the item that we're going to mould. So we're now defining how big do we want that cuboid around our reference model. And the way that we do that is we click on workpiece, because that cuboid, if you like, is known as the workpiece. So click on the workpiece button. We need to put two things into this workpiece creation box that we've been confronted with. The first thing that we need to define is what coordinate system are we going to use to define this box, and the one that we're going to pick is the top level assembly coordinate system here in the model tree. So I'm just going to click on that coordinate system. You can see that's now being collected into this mold origin input box, and then what I can do when I've done that is just put 10 for 10 millimeters, press enter, and what that does is it offsets my cuboid away from the reference model by 10 millimeters in every direction. So that's X, Y and Z directions, and you can see that below in all these 6 boxes. So if I want to put some custom offsets in a particular direction, I can then edit these values and maybe have 20 or 30 or whatever value I require in whatever direction, but we'll accept this 10 millimeters in all directions for this particular example. So I'll click on OK. The reference model gets created, so it's represented as this transparent green box, and there it is in the model tree. So the next step that we're going to do is we're going to account for any material shrinkage that almost inevitably occurs when you plastic injection mold parts. So the general process is that you will inject molten material into the mold cavity, heated molten material. The molten material will flow into the mold cavity, fill the mold cavity, and then normally the mold is cooled down relatively rapidly, and what can happen, or what tends to happen, is the plastic that's been injected shrinks slightly. So in order to account for that, what we need to do is create a cavity that's slightly too big, so that's slightly bigger than the final part that we require. So we're going to do that now, and the button to do that is the shrinkage button here. And then there's two things that we need to enter here. There's the shrinkage ratio of the plastic that we have chosen to use. So I'm using just a generic plastic. I haven't defined specifically what plastic I am using at this point, but I'm using just a typical generic plastic. And I'm imagining the shrinkage factor of, or the shrinkage percentage of this plastic is 1%. So if it's 1%, we must convert that into a ratio. So 1% becomes 0.01 as a ratio, because obviously the relationship between ratio and percentage is a factor of 100, either divide or multiply. So 0.01 represents 1%. The only other thing that I need to define is a coordinate system, and in this instance I'm going to use the coordinate system which is inside the reference part, or the reference model. So I'm going to go over here and I'm going to browse inside the reference model, and then I'm going to browse inside this little subfolder here, and within there are all the features that I created when I designed the part. So there's a default coordinate system in there, so I'm going to select that. Now it hasn't entered it into the box here, so I'm just going to click on that arrow again and just do the same thing. Now it's collected it. So now we can preview what the shrinkage is going to achieve. So if you keep watching the reference model and then click on preview here, hopefully you notice that the reference model grew slightly, and the amount that it's grown by is 1% in all directions. So we can OK that. We've accounted for the shrinkage, and the shrinkage as a feature in this setup gets stored within the reference model itself. So there's the reference model in the model tree, and if we need to edit the shrinkage at any point, we can browse inside that, click on the shrinkage, go edit definition, and we're back in the shrinkage menu. So say we wanted 2%, we could put 2% in. We don't want to do that at this point, but it's good to know how to do that if we need to further on in the design process. So let's refer back to our PDF, see how far through we've got. So we've done these steps, we've brought the reference model in, we've created our workpiece around it, we've applied a shrinkage ratio. So the next step here is to define two items, one of which is known as the silhouette curve, and the silhouette curve is essentially the shape of the outside of the part that you would see if you were looking down from above onto the part. So it's that external silhouette of the part itself. It's all the outside edges as a curve, essentially, or a line. You can almost regard these as a sketch. So it's a single line that traces all the way around the silhouette of the part. And the reason that we need to create this will become clear in the next step after this, where we use this silhouette curve to create a collection of surfaces that ultimately allow us to split the mold into two sections. So we're essentially creating, if you want to think about it like this, a cutting tool or a knife edge to actually split the mold in two. So silhouette curve, there's a button for silhouette curve, we'll click on there, and really all we've got to do at this point on this particular example is just zoom in and inspect this curve and just check that, does it seem to be complete? It does. It seems to trace the entirety of the outside of the part. Another thing to check is, am I getting a preview at all? So sometimes if there's some error in the geometry of the part, you may have to go back and correct that to get the silhouette curve feature to work, but this one seems fine, so I'm just going to OK that. And then that curve is now selected, which is why it's highlighted in green. If I want to deselect it, I can click into some empty space over here, and then the curve is still there, but it's in this kind of pale blue colour now, and it's been entered into the model tree over there. So the next step that we need to perform is we need to use that silhouette curve that we've just created to generate what's known as a parting surface. So you can see the parting surface tool here, and as I've already talked about, you can think of the parting surface as a cutting tool that we will eventually use to split this block into two halves. So if we have a quick look at the PDF that we're working from, and then scroll down a few slides, this is essentially the beginning of the creation of that parting surface. So you can see the surface previewed in this kind of orangey yellowy colour, in the same way that we get previews for most of the features in this colour. And essentially what we're going to use is we're going to use the extend curve tool. So that is a subsection of the parting surface tool itself. So let's start doing that now. So if we go back to our Creo session, so I'm going to click on parting surface to tell the system that I intend to create a parting surface or a collection of parting surfaces. And then within the parting surface tab, we have these tools here which allow us to generate surfaces in certain ways, and by far one of the easier tools to use is the extend curve tool. and this will extend our silhouette curve that we've already created outwards towards the outside surfaces of our reference block. So our reference workpiece that we created, this green block, it will bridge the gap between the edge of our reference part and the edge of our workpiece. So let's initiate that. So extend curve, and then because we're arguably new to this process, it might be useful to open some of the further details within this feature, this extend curve feature. So I'm going to open this extensions tab, and then what I'm going to do is I'm just going to zoom in a little bit here, and I'm going to start clicking on portions of the silhouette curve that I previously created, and hopefully you can see what's happening in the preview there. As I click on the curve, it does essentially what I've just talked about, which is it bridges the gap between that curve and the outer surfaces of my workpiece block. And on a lot of the curve that we've generated here, that will suffice, that will do the job of creating our parting surface. However, there are certain little areas down near the clip features here, specifically these near vertical edges and this edge that you could in some senses regard as an overhang, and this edge down here as well, that cause the extend curve tool not to work correctly for these specific sections of the silhouette curve. So we're going to leave those ones blank, and we're going to come back and we're going to tackle those ones with a slightly different surfacing tool. But everything else on the silhouette curve, so this edge here and this edge here and this edge here, and then continuing round the front of the part here, so all these subsequent edges, we can just use this extend curve tool to generate our parting surfaces from. So I'm just working my way around here. For this particular tool, I don't have to hold down Control to select all these edges, and that's because it's collecting each little edge that I click on as a separate selection, if you want to think about them like that. So you can see it names them all extension because it's extending a surface away from that silhouette curve. And if I click on extension 1, it highlights in green what specific piece of the edge or piece of the silhouette curve extension 1 is coming from. So in that way, if I need to delete anything, if I click on something by mistake, I can find it in this list, right click and say remove, and it deselects it essentially. So yeah, we can add things to the list of extensions, we can delete things from the list as well. So I'm just completing selection of all the edges that I want for that tool. So this is the final one down there, and then that's done the majority of the job for us now. It's done maybe more than 95% of the total silhouette edge, if you want to think about it like that. The only ones that we're going to have to tackle with a slightly different tool are these little kind of overhangs and near vertical edges. Now you can try clicking on these just as an experiment to see what happens. So if I click on this one, yeah, you can see some of the problems there that we're going to have. So that doesn't seal up the gap that we have here between these two surfaces. Instead, it incorrectly chooses the wrong direction to extend off into, and that will cause problems. So we don't want that. So that is extension 21. So if I just right click on it and press remove, that will get rid of it. So we're going to OK that tool, the extend curve tool, and we've got the majority of our surfaces there. Now we need to look to a slightly different surface tool in order to patch up this gap that we've left here. So there's a gap between this upper surface here and this lower surface. You can see as I'm moving my mouse pointer around, the system's trying to select the workpiece itself. And that is quite annoying. That's not really helpful when we're working on these surfaces. So what I'm going to do is I'm going to hide the workpiece temporarily. So if I find the workpiece in the model tree over here, just click on it, and then that is the icon to hide something in the model tree. So I'm still in the parting surface tool, and then within the parting surface tool I'm going to now use the boundary blend surface tool or surface feature. So boundary blend, and what I'm going to do, again, I want some further detail about this feature. I'm not happy at this point, I'm not confident enough with the system to just start clicking on things. So I'm going to click where it says curves here to open up some further detail, and then I'm also going to click where it says details here, and that allows me to kind of more fully appreciate what I'm actually doing. So then what I'm going to do, I'm going to click on this lower edge to collect it into this references box, and then hold down Control because I want to add something else to it, and I'm going to click on this edge here because I want to add those two edges together into what's known as a chain of edges. So I have to hold Control to select this second edge. Now if your system's trying to display the entirety of the silhouette curve when you try and select this edge, you can try right clicking the mouse button until you can just select this little short edge here. So I'm holding down Control now and I'm clicking on that edge. Then the edges that I've selected there highlight in green, and they get entered into this references box here. So that is the slightly shorter one, the one that's part of the silhouette curve, and this is the slightly longer edge, which is the edge of this existing surface. So they've now been added to this first chain. So I want to create a new chain, so I'm going to click on Add. So that first chain is still there. Now I'm selecting things to add to a second chain. So I'm going to do a similar thing up at the top here. I'm going to click on this edge first. That edge gets entered into the references box, and then I'm going to hold down Control and I'm going to select that little edge there and click. So both those curves or edges have been collected now and added together into this second chain here. So at that point I don't need to collect any more chains, I just want to click on OK and see what this boundary blend feature is going to look like in the preview. So OK, and that's what it's going to look like. So it's going to look essentially like a planar, flat surface. So that looks OK. Now, just as a slight aside there, it's got nothing to do with the boundary blend tool, but when you're working on a part and you're zoomed in to quite a high magnification like we're doing, so the part itself is relatively large compared with the area that we're actually working on, then it can be useful to switch this option off. So I have this switched off currently, and that is the spin center. So if you have that switched on, which is the default setting, and you try and hold your middle mouse button and rotate your view, that is what tends to happen. The thing that you're working on disappears from view, and you have to do some work to get it back into the viewing window. Whereas if you turn that option off, any item that you have highlighted under your pointer, like this edge in orange, that is what your view then rotates around. So you can see hopefully that that's a little bit easier to work when you're zoomed in quite a long way on a part like we are. So I'm happy with that boundary blend, so I'm going to click on OK. So there's my boundary blend surface. There it is. It's patched the hole that I previously had there, and I'm happy with it. So if I click on it there, it highlights the surface in green there. So what I'm going to do now, I'm going to create a second boundary surface. So I'm going to make sure I've got nothing selected just by clicking in some empty space. Click on boundary blend again, rotate my view a little bit, open up the details tabs, so curves and details. So this allows me to see what I'm actually doing a little bit more clearly. So if you remember, we're going to collect a first chain, and then we're going to add a new chain, and we're going to collect things to put in the second chain. So the first chain is going to be this edge, and then hold down Control, and then I'm going to add that little edge there to it. So I've got those two edges in the references box. They are now collected as this first chain. I want to add a new chain. So click, I'm now adding a new chain. So I want to do the same thing, but on that edge there, and then hold down Control, and that edge there. So I've collected those two edges, and they are now the second chain. So this chain here. So then I'm happy. I want to see a preview of what that boundary blend surface is going to look like. So I'll click on OK. Yep, again it looks good. I can't see anything wrong with that, so I'll click on OK. So there's the boundary blend. So they look okay. So at this point, if we just refer back to the PDF, we've essentially we've completed all these steps. These are all related to the extended surface that we did first. So this is the first boundary blend that we created. So we're coming up to the point that we've actually reached. This is the point. So when we've created two of these boundary blends, what I did originally when I wrote this PDF was I used the mirror tool to mirror these two boundary blends over to the other clip on the other side of the part. Now that did work originally, but when I tried to replicate it on the university machines, I was getting some errors. So what I'm going to show you now is a slightly different method, and this method is just going to involve doing exactly what we've done for these two boundary blends, but on the other side of the part. So this method seems to work regardless, whereas the mirror command, it was working and then it didn't work when I demoed it again on the university installations. So let's do the boundary blend tool again. So we'll click on boundary blend, open up the curves tab, open up the details tab so that we can see what we're doing. Should be reasonably quick at this now. So it's this line, hold down Control, this line, add a new chain because we've completed this chain, this collection of two lines, new chain. Then I can't see the two lines that I want to work on, so I'll just rotate my view a little bit. So it's this line, hold Control, and this line. So there they both are. And if you hover over them, they highlight in orange to show which reference is which. So we've got our two chains of edges. Click on OK to see the preview. The preview looks okay. Click on OK. And then we've just got one last boundary blend surface to do now. So boundary blend. Click on this line. I didn't open the curves tab. So details. So here we are. We've already got the first edge selected, so I just need to hold down Control. Now this is quite good. So what is happening here is it's not letting me click on that little single edge. It's trying to select the entirety of the whole silhouette curve itself. So you can see that highlighting in orange. Now that is not what I want. So if you get into this situation and you know there's an edge under your pointer somewhere, you can press the right mouse button, and what that does, if you just keep pressing it, it cycles through all the things which are underneath your mouse pointer. So there could be multiple things. So you can see there's a pair of faces there that are underneath my mouse pointer. There's the entire silhouette curve, and if I click again, there's the edge that I want. So when you get to the one that you want, you can hold down Control. So I'm just pressing it again to get to the one that I want. So you can see I'm cycling through the things underneath my pointer. That is the one that I want. So then I can hold Control and click. So that may take a little bit of practice to do that, but if you end up selecting the wrong thing, just find the thing that you've selected in error in the list here, and you can right click and remove it. So let's do it again. So I'm holding Control, I'm pressing the right mouse button till I find the one that I want to select, so it's this one, and then I click and it adds it into the box. So we've created the first chain, we want to add another chain now. So I move my view a little bit so I can see the lower edges. And then I'm going to select this edge first, it gets entered into the box, hold down Control and select that edge. So that should be okay. The preview looks good. Okay, the boundary blend. So we've got a complete parting surface now. So you can see the parting surface kind of fills all the gaps in between the edge of our reference model, which is a copy of our part, and the outer faces of the workpiece, which is currently hidden. And I've just shown it again just to illustrate that the parting surfaces bridges the gap. So that will help us when we come to split this mold tool into two halves. The parting surface will allow us to define what that split surface will look like. So that is why we create the parting surface. So I've just got one last step that I need to perform to complete that parting surface. So what I need to do is I need to merge those 5 separate surfaces into one complete continuous surface, so that when I come later on to tell the system this is the surface that I want to use as the cutting tool, I don't have to select each one of those surfaces individually, or rather the system won't allow me to select each one individually. I must unify them or merge them into a single whole surface. So we're going to do that now. And it might be more useful to hide the workpiece again before we begin this. So I'll hide the workpiece. And then what I'm going to do, down at the bottom right here, there's a little what's known as a selection tool. And what we've had it set on is to filter our selections to any geometry at all. So that really isn't a filter at all. It just allows us to click on any edge or surface or feature or datum plane or axis. It allows us to essentially select anything. But what we want to do for this stage is we want to limit ourselves to only be able to select quilts, which are kind of another term for surfaces. So if we set that to quilt and then zoom in a little bit, what I'm going to do is I'm going to select that original surface or quilt, so the big surface that we created first, so that would be this one, and that highlights in green, so you can see those are all the faces that we created with that big original surface, the extend curve surface. Then I'm going to hold down Control and I'm going to go around selecting all of the other little surfaces that we created. So there's 2 on that side, so I'm holding down Control as I click on them. So click and click, and then some options should pop up in my quick access menu there, and the one that we want is this one. So if you hover over it for a second, it tells you that it's the merge command, and this merges 2 or more quilts into a single quilt or a single surface. So merge. And then the preview isn't that spectacular on this one, but I'm going to assume that it's okay and there won't be any errors when I click on OK here. So I'll click on OK. Yeah, the merge feature seems to have completed successfully, otherwise I would be seeing errors represented with little red icons in the model tree here. So we've done that step. So we can now click on the entirety of those surfaces, all 5 of them, and they highlight as a single piece of surface geometry. So that's that step done. So let's have another look at the PDF. So we've bypassed the mirroring command. We used the boundary blend command another 2 times to achieve what we would have done with the mirror command. Then we merged all the surfaces together. So the next step here, if we read the text, next we will use the reference part, so that is our shape of our part that we want to mould. We'll use the reference part as a tool to cut away material from the inside of our workpiece. So this is making essentially a piece of missing geometry inside the workpiece. So this would be the cavity where the molten plastic gets injected into. So this is the tool that we're going to use, ref part cutout, because that is essentially what the tool is doing. It's using the reference part to create a cutout in the center of the workpiece block. So let's get that working now. So what I have to do first is I have to exit out of my creation of parting surfaces. So you can see I'm still in the parting surfaces tab here. So I have to OK all operations to do with parting surfaces. And the way that we do that is that small tick at the right hand side. So in the same way that when we're in any tab within Creo, if the tab is active, it will tend to be at the rightmost of the screen, and it will be highlighted in that light grey colour. And that means that we have to either cancel what we're doing in that tab to go back to the previous tab, or we have to OK the edits that we've done and accept them, and then that tab will close and we will go back to the previous tab that we were working in. So in our case, we're back in the moulding tab. So what are we going to do? We're going to do a ref part cutout. I think what I'll do is I'll show the workpiece, just because there's no reason to keep it hidden now. So show the workpiece. I may even put my selection filter back to geometry, so everything essentially. So ref part cutout. Now we as the user in this instance have to do very little here, because of the setup that we've created, where we've got a single reference model and we've got a single workpiece. The system has already selected both of those items, so it's found the only reference model that we have in this setup and it's entered it into this box here. So handle, front, mold, reference. So it's selected that, and here's the workpiece model, handle, front mold, workpiece. So it knows that those are the two things in this setup that represent the workpiece that is going to be cut away, and the reference part that's going to do the cutting. So we don't really have to do anything. So we can just click on OK now. So what that has created, it doesn't actually cut a hole in the middle of the workpiece. What it does is it creates a copy of the workpiece down here, and it cuts away the center of that. So in this way, the system is creating new features down at the bottom of the model tree. It's not being destructive to the existing features. It's creating new copies of them that have, in this case, the cavity missing in the center. So it creates this new feature. So if we hide some things here, so if we hide the reference model, and if we hide the workpiece, maybe even hide the silhouette curves, so we've hidden all that original all those original blocks and shapes we can no longer see. So the only real thing that we can see are some surfaces and this new ref part cutout. So this should be a copy of the workpiece block, but with the shape of the reference model missing out of the inside of it. So let's see if it is. So what I'm going to do now is I'm just going to cross-section this thing temporarily to check that it has actually done what I've just said. So I'm going to click on the View tab, click where it says Section, probably click on this end face, and then drag the cross-section through the part. And if we look down into the block itself, it does appear to have done what I said it will do, which is create a copy of the workpiece and then remove a shape from the middle of that block which corresponds to the outside shape of our reference model. However, it has created all those things as just surfaces, so you can see it's actually a hollow block. So the outside surfaces of the block are represented with these flat surfaces. The inside missing portion is represented with a bunch of surfaces that kind of define what bit of it is missing. But the area in between those two, so from the outer surfaces inwards towards the cavity, is all hollow as well. So it's kind of achieved what we want, but none of this is solid material at this point. So there's a few more steps that we have to go through in this process to create some solid parts that we could, let's say, CNC machine to create the mold. So we're part of the way there, but we still have to go a little bit further. So we're at this point in the PDF now. So let's go back to what we were doing. I don't need this cross-section view. I only initiated this section view just to check what the inside geometry of the ref part cutout looked like. So I'm going to cancel the section view. I don't want to save it. So cancel. Do I want to cancel? Yes, I do. I need to go back into the molding tab because I'm going to do something else. So if we have a quick look at the PDF, what's it telling us to do? It's saying now we use our parting surface to allow us to split the mold volume ref part cutout 1. So ref part cutout 1 is known as a mold volume, and we're going to use the volume split tool to split it into two pieces. And the volume split tool needs a ref part cutout feature, which we already have, we've just created that, and it needs a parting surface to split that ref part cutout into two halves. So let's do that. So it's in the mold volume drop down menu. So here we are, and if we have a look in the mold volume drop down, there's the volume split command. And again, because we're relative novices at this, it will be useful to see what the system is asking of us in a little bit more detail. So if we click on the reference tab, it's essentially waiting for two inputs. The first input is what volume do we want to split. So that would be this ref part cutout. So ref part cutout is what we want to split. Split surfaces, so I'm clicking here. If I now hover over where I know my merged surface is, it will highlight. So that is my merged surface. So if I click on that now, and then if everything's successful, I will get this yellowy kind of preview of what's going to happen. So that's not particularly informative, but it is reassuring that I do have a preview, and that means that I'm reasonably confident that this feature, this volume split feature, will work, that there's not going to be any errors with it. So if we click on OK, it appears to have worked. But what it's done, just like we saw before, is rather than deleting the ref part cutout itself or modifying the ref part cutout itself, what it's done is it's taken a copy of ref part cutout and it's created the upper half of what we require, so the upper half of the mold, and it's created the lower half of the mold. So we still have ref part cutout as an unmodified item. That is a block with a cavity missing in the middle that we created. So this is how the molding tools within Creo work. They're what's known as non-destructive. They don't modify any of these features or parts directly. They always create a copy in the model tree, and it's the copy that is modified. So you can always go back one step. You can always go back to either the step where we did the ref part cutout and edit the definition if you want to, or you can go back to the original reference model and maybe make a change there, or the original workpiece and maybe make a change there. So it always creates a copy of the thing that you're editing, and it edits the copy rather than making any changes to the original. So you can always go back to a previous step. But what it does mean is you have to get into the habit of hiding things in the model tree, because otherwise you'll get lots and lots of features and lots of geometry that is all on top of one another, and it becomes very difficult to select one thing versus another. So it's useful to be able to hide some of these features and parts that are higher up in the model tree. So that's what I'm doing here. I'm hiding ref part cutout 1 because we've finished with that step. I can just see my volume split 1, which is the mold upper, and my volume split 2, which is the mold lower. If I want to inspect them independently of each other, I can hide one of them. So that's the lower section that I've created of the mold. And then if I show the upper and hide the lower, that is the upper section of the mold. So we're almost there now. We've almost created our two-piece mold, or our two-piece molding tool. But these upper and lower tools are still hollow. They are still just a collection of surfaces. So if we want to check that, maybe we don't believe that at this point, we can click on the view icon again, go back to section view, click on one of the end faces, drag that section view into the part, and then stare into the part there. So you can see, hopefully, that is a hollow collection of external surfaces. So it fully describes the shape, the external shape of our mold, but it's not yet considered by the system a solid block of material. It is a hollow collection of zero thickness surface faces. So that's the key thing there. These surfaces have zero thickness, so they're a purely mathematical concept. They cannot exist in the real world yet. So we can't export these two halves of the mold out as usable Creo parts yet. So there's one more step that we must do. So I'm going to cancel that cross section. Do I want to cancel? Yes, I do. I'm going to go back into the molding tab. I'm going to have a quick look at my PDF guide. So we've done our volume split. We selected the splitting surface. We isolated and inspected the individual volumes that we've created. So there's the mold lower half and there's the mold upper half. And there are the two volumes in the model tree. We've appreciated that they are merely surfaces and that they're hollow and can't be used for parts or for manufacture. We must convert them into actual usable solid parts. So this is what we're doing in this step here. So this is the tool that we're going to use. It's inside the mold component drop down and it's cavity insert. And if we read what it says about the tool, create cavity insert parts. So parts is the key word there. These are going to be real parts, real solid parts from mold volumes. So these were the mold volumes, volume 1 and volume 2. And this tool takes those mold volumes and creates actual parts from them. So this is what we're going to do next. So mold volume cavity insert is what we're going to do. So it may be useful to show both of the volumes. It's not essential, but I'm going to show this volume. So there they both are. So it's mold volume, mold component, cavity insert. And then essentially what it does is it scans the entire model tree for any mold volumes and it lists them in this window. So we have two. There they are. Mold volume 1, mold volume 2. One for the upper, one for the lower. And any of these that we now wish to create solid parts from, or real Creo parts, we just select them in the list. So I'm clicking on the first one, holding down Control, clicking on the next one. And then if we wanted to give them a more descriptive name, we could do here. We could change the names from volume 1 to mold upper or mold lower or mold cavity and mold core. But we're not going to do that in this particular example. Just know that it is an option. So I'm just going to click on OK. And then just as it's done before, the system has inserted some new features or some new parts down at the bottom of the model tree. So the volumes are still there, the surface volumes, but it's now created two parts. And I know these are Creo parts because they have the .prt extension on them. So if I want to check what these are, I now have the luxury of opening them up in their own part modeling window. So I can click on one of them in the features tree, go up to open, and here is the part in its own part modeling window. So I could then take this part onwards and maybe do some more manufacturing activities, such as creating a CNC program to machine this out of a solid block of material. I could use this part for activities such as that. And if we want to check now, is this actually a solid block of material, we can do the same cross-sectioning technique that we did before. So if we click on view, click on section, click on one of the end faces, and there we go. It's no longer a hollow collection of zero thickness surfaces. It's actually solid material all the way through. So that you can regard as a genuine Creo part that you can then use for other activities, maybe further down the manufacturing timeline. So that is our part. If we want to go back now to the assembly, we have to go to this icon here, which is lists any windows that we have open within the Creo software. So there's our manufacturing assembly. So I'll click back on there. And then if we just want to check the PDF, so if we just have a quick look. So we've created the 2 volumes. We selected volumes 1 and 2. We now have these solid parts. We can inspect the solid parts within their own part modeling windows if we want. There's the other half of the part. So the end section here is just highlighting the fact that this is a very basic workflow of how to create your 2-piece mold. There are further molding tools within the molding environment, and some of them are highlighted here. So you can insert runners into the mold. So runners would be the pathways down which the molten plastic will be injected through into your mold. You can insert mold features such as ejector pins, which when the molded part is reasonably solid, so it's almost fully solidified, the ejector pins will push the part off the mold half that they may be gripping onto, despite their draft angles. So you can add a whole plethora of extra mold furniture into your mold designs, but this tutorial purely covers the main setup steps, those 9 steps that we talked about back at the top of the PDF there. So here they are, just to create your basic mold halves or mold parts. So yeah, I encourage you to have a little look at some of the other molding tutorials which are contained within this week's learning materials. Have a little play around with some of the other tools. Start thinking about how you might apply what we've done here today to the tasks that you've been set in your project work as well, because there's a specific section within the project that deals with or that requests that you create a molding tool of your rear cover that you're going to design for your knife. So yeah, this is very much, it helps you in that process. If you try and replicate what we've done here today in that section of your project, then you should be fairly confident that you will get the majority of the marks. So one final thing here, obviously we've created an assembly here, you can see, because it's got an ASM extension on the file name. So if we want to take a save of this, we just click on save. It navigates into our working directory, and we just click on OK, because we've already given it a name. We don't need to type a name or anything like that, so we click on OK. So it's taken a save of that, and it will have saved the overall assembly, so we can come back in here and make changes if we need to, but it will also have taken a save of these 2 part files into that working directory. So you can now use them, you can load them up and use them in other processes, as we've talked about. Maybe CNC machining processes where you will want to CNC machine the mold shape from a block of solid material. So yeah, that's the end of this tutorial. and we will continue the moulding process next week with some analysis of the actual moulding process itself. So analysing things like mould temperatures and injection times and injection pressures and different types of plastic, things like that.